Hey everyone, and welcome to this explainer for the Foundry by Forge College. So if you were with us for our last lesson, where we walked through creating a basic project with Anchor, you know we laid down some serious groundwork. We got our project scaffold up and running. Well, today we're taking a massive step forward into the Anchor Framework Essentials module. We're going to examine the absolute master blueprint that glues your entire decentralized app together. Yep, we are talking about understanding Anchor.toml and program IDs. We'll break down the exact structure of that configuration file and figure out how program IDs are referenced inside it. Trust me, getting a grip on this early on is going to save you literally hours of frustrating debugging down the line. Let's get into it. Okay, here's a quick look at our roadmap for today. We're going to cover the master blueprint, the actual anatomy of the Anchor.toml file, the crucial Rust connection, what I like to call the environment dance, and finally, a few configuration golden rules to live by. All right, part 1. The master blueprint. You know, it's super easy to open up an Anchor.toml file and just see, well, a pretty dry, boring text file full of brackets. But honestly, it's so much more than that. It's the master engineering blueprint telling your entire application exactly where it lives on the Solana network. But before we start messing around with it, we've got to define our absolute most important term here. What exactly is a program ID? Well, think of it like a phone number, a highly specific, unique blockchain phone number. Technically, it's the immutable public key that permanently identifies your on-chain program. Think about it. If you want to interact with your app, you have to dial that exact right number. If you don't, you're basically just calling out into the digital void. Moving right along to section 2, anatomy of Anchor.toml. Okay, let's zero right in on the programs.cluster block inside that file. Basically, you can think of this as the address book for your project. What it does is map a nice, human-friendly package name, something like my_program, directly over to that incredibly long, complex base58 encoded program ID we were just talking about. When you're running commands, Anchor actually flips through this exact address book so it knows precisely which public key it needs to target for whatever specific network cluster you're on. Next up in the file is the provider block. Now, this sets your default cluster and the path to your wallet for any CLI commands you run. And listen, this is absolutely your safety net. Leaving this default set to localnet while you're doing local development is, well, it's just a very, very good idea. Why? Because accidentally leaving this set to mainnet while you're iteratively testing some broken, half-finished app is a fantastic way to involuntarily sponsor the Solana network with your own real money in gas fees. Yeah, let's definitely avoid that, shall we? And rounding out our little anatomy tour here, we have the workspace block. If you're building multi-program projects, this section is an absolute lifesaver. It just lists out the member packages. This way, the Anchor CLI can easily navigate around the project, finding build artifacts and IDL outputs automatically. So instead of you having to manually point the CLI to the right files every single time, it just knows exactly where to look. So, to bring this all together across different networks, you're going to want to maintain distinct environment bindings. Notice how we separate things out into programs.localnet, programs.devnet, and programs.mainnet. Keeping these bindings totally distinct under different clusters, rather than just constantly overwriting one single value over and over again, is so important. It keeps your history clean, and it makes switching context between testing and production totally painless. All right, let's jump to section 3, the Rust connection. Now, I want you to think of this connection kind of like that red string on a crazy investigator's corkboard. Right, on one side we have our Anchor.toml file, clearly stating the program ID. But then on the other side, deep inside your actual Rust code, we have this declare_ID macro using that exact same string. This is a massive aha moment for a lot of devs. These two elements must perfectly synchronize. Your configuration file and your actual source code absolutely have to agree on what the program's phone number is. So why are we so strict about this? Well, it's because that declare_ID macro actually embeds the expected public key directly into the compiled binary of your program. If the macro inside your Rust code and the string sitting in your TOML file are mismatched in any way, Anchor is just going to throw its hands up. It won't know how to resolve the accounts. And if that happens, you're going to find yourself falling back on the classic, well, it works on my machine excuse, while your deployment totally fails in front of everyone. Okay, moving right into section 4, the environment dance. So, how exactly do we prevent those embarrassing mismatches? We do what I like to call a methodical deployment dance. It goes like this. Step 1, you always build and deploy locally first. Grab that local key, Step 2, set your provider cluster accordingly so you're testing safely in a sandbox. Step 3, when you're fully ready, you promote the app via continuous integration up to devnet or mainnet. And finally, step 4, immediately update that specific programs.cluster ID right in your TOM vault with the newly allocated key. Sticking to this routine keeps your configurations predictable, safe, and easily auditable. Honestly, I really cannot stress enough how important this workflow is for your career. In fact, mastering these kinds of multi-environment deployments and building those bulletproof, reliable habits, that is a core part of the practical developer learning programs we focus on at Forge College. Because at the end of the day, real-world deployment practices like this are exactly what separates amateur code from professional-grade Web3 engineering. And finally, Section 5, Configuration Golden Rules. Okay, to make sure you walk away today with some solid, reliable habits, just remember these golden rules. Number 1, treat your program IDs as environment bindings. Always keep your local, devnet, and mainnet keys completely separate. Number 2, manage those provider clusters intentionally so you don't accidentally deploy straight to the wrong network. Number 3, always synchronize your Rust source code macros with your TOML configurations. And finally, if you just need to do a quick test, use CLI flags for one-off operations rather than completely rewriting your core configuration files. Seriously, if you follow these rules, your runtime resolution issues will basically drop to 0.
So, here we are. We've organized the address book, we know the blockchain phone number, and our engineering blueprints are perfectly aligned. But that leaves us with a pretty massive question for our next explainer. How will your actual Rust code enforce account ownership securely once that program is running? It's a big topic, and we're going to dive really deep into the Rust programming model next time to figure it out. Until then, make sure you visit forge.college to learn more about this subject and to explore a ton of other really fascinating Web3 topics. Keep building, stay curious, and I'll see you in the next explainer.